I have to say, when Ian first approached me to ask if I wanted to speak at this event, at first I was kind of scratching my head as to the fit. How do you slot in a nutritionist amongst this very distinguished lineup of speakers? But when he told me the theme of challenging assumptions, I had to admit that nowhere are there more assumptions that need challenging than in this world of nutrition and health. And just to kind of test that theory by show of hands, how many people in here think that the subject of nutrition is kind of confusing? Okay. Yeah, I think that's partly because many of us get a vast majority of our nutrition beliefs from the media, who you could argue are kind of more interested in catchy headlines that sell newspapers than kind of interpreting scientific research, which might explain why a lot of the headlines kind of contradict themselves, let alone government guidelines, which I have to say, for the most part, are over 20 years old. The science has moved on. And it's a fascinating field of study to be involved in today, because on the one hand, you have this growing awareness and interest in health and nutrition in the public, and on the other, you have this rising tide of chronic disease. The World Health Organization are now estimating that by 2020, which is like, tomorrow, 2/3 of all disease globally will be directly attributable to lifestyle choices. And the biggest lifestyle choice that we make every single day, multiple times, is what we eat. The top 5 killers today, type 2 diabetes, heart disease, stroke, Alzheimer's and dementia, even many cancers, are what you call lifestyle diseases, which is basically saying that we are today living and eating in a way that kind of contradicts our ancient genetics. And that's kind of a clue to what I want to talk about today. I thought rather than stand up here and just bust all the key nutrition myths, and there are many, or rattle off the key principles to good nutrition, I thought I would kind of up-level this conversation and challenge some of the more fundamental assumptions around what is nutrition and how does it relate to human health, and how did we end up where we are with this so-called Western diet, arguably the biggest killer of them all, more than smoking, according to the Daily Mail. I think they got that one right, actually. So to start this discussion, I think we have to start with this kind of a very fundamental question of what is health? Right? And I would suggest that health is not necessarily a static state, but it's a continuum. All right? And if on the far right we have optimum health and vitality, and on the far left you've got death, then if your heart is beating, you're somewhere on this continuum. Okay? And the work that I do clinically involves working with the individual to try and kind of figure out where they are on this continuum, and more importantly, how did they get there? Because 10 people with the same set of symptoms got there 10 different ways. And at a very simplistic level, it's about removing the obstacles and adding the missing pieces that help to shift that individual towards health and vitality on the continuum. The human body has this incredible capacity to heal itself if we can just get the heck out of the way a lot of times, right? So I think to kind of kick things off, we need to maybe peel the onion a little bit and look at just what it is we're made of first, right? And that is cells. We're made up of about 10 trillion cells, give or take, but we only have about 300 different cell types. We've got kidney cells and liver cells and bone cells and brain cells and skin cells and on and on and on. And we kind of forget that cells don't just sit idle. They have functions to perform. And depending on the cell type, determines the cell function. Some cells are very, very busy. Let's take the liver, for example, one of the busiest organs. It's the home of energy metabolism and detoxification. And it's the cells in the liver that have over 500 different functions to perform, whether it's making an enzyme to convert fructose, a sugar found in fruit, into fat, or vice versa, or to take a toxin like caffeine and convert it so that we can excrete it in our urine, and on and on and on, right? And in order for these functions to occur, they happen by way of chemical reactions, okay? And these chemical reactions happen thousands of times a second in every single cell of our body. In order for those to work, they need kind of raw ingredients. You know, we need glucose, we need oxygen for energy, and then we need these things called cofactors to make that chemistry work, all right? And those are called micronutrients, right? Vitamins and minerals and amino acids and fatty acids. There are about 40 that we call essential micronutrients. And we call them essential because we don't make them ourselves, so we have to get them from our environment. And they're also essential because if we're missing any one of these, we get sick and die pretty quickly, all right? So it kind of stands to reason that if we're missing one of these, we die. That if one or several of these are in kind of low levels, our chemistry might not work optimally. Kind of logical, you know, optimum health requires optimum nutrition, all right? And so where do we get these cofactors, right? Well, we get them from our food, okay? And now I'm an old IT guy. I did 25 years in the IT industry before shifting into nutrition. And so I like to use analogies. So let's say we can think of our genes as kind of providing the hardware, let's say wiring, that tell our cells what to do and how to do it, okay? And we all know that hardware needs software to run, okay? Software is basically the information that enables the hardware to kind of run and execute and function. So you can kind of look at food as providing that kind of software information that enables our hardware to kind of run properly. And we can either provide the right information to our cells or the wrong information to our cells, okay? So foods like this are what I call kind of energy-dense foods. Lots of calories, but they are nutrient poor, hardly any micronutrients, okay? And because eating is kind of a zero-sum game, we can only eat so much food. So the more of one food we eat, the less of another food we eat. And so the more of this type of food we base our diet around, the more likely we are to end up with micronutrient deficiencies. And we actually get into a state where we're overfed, but we're undernourished, okay? And that is a recipe for chronic disease, plain and simple, okay? So that's kind of a level set that I wanted to lay on you before I kind of shift to the next part of the story, which is really about kind of how this relates to us as humans. And to tell this part of the story, I want to kind of wind the clock back a few years, 2.6 million years to be more precise. Okay, we evolved as hunter-gatherers, okay, and our ancient kind of hominid ancestors foraged for seeds and berries and fruits and nuts and roots, and we would fish, and if we were skilled with a spear and lucky, we'd take down a wild deer and eat every last bit of it, okay? We spent a huge amount of energy every day in the quest for nourishment and food. We had a very diverse diet because we didn't choose what we ate. We ate what we could find where we could find it. And so it consisted of lots of different, very nutrient-dense foods, okay? And we didn't eat that frequently either. You know, there were times where food was not always available. So our ancient genome evolved to this environment that our genes were exposed to, of lots of energy exertion, very diverse, nutrient-dense diet, and infrequent feeding, okay? And that went on for a couple of million years. And then around 10,000 years ago, something massive happened, and it was this shift from hunting and gathering to farming. We learned how to plant crops and master animal husbandry, okay? And that changed everything. We no longer had to move seasonally a few times a year to where the food was in these little manageable packs of around 25 people or so. We could kind of bunker down and stay put and grow bigger families because our food source was stable, and we could specialize. We could become stonemasons or shoemakers or teachers and trade our expertise for our stable food source. And civilization emerged as a result of this model. It was a very successful model, but there were some side effects. Some of us got a little sedentary. Our dietary diversity shrunk massively because now we were reliant on these staple food sources, okay? And with loss of diversity of diet comes loss of micronutrients, right? Another interesting thing happened was the introduction of dairy and grains into the human diet, which up until that point there was no genetic precedence for. These foods did not exist in our diet. I mean, how would you milk a wild animal? Just didn't happen, right? And grains, wild grains, they just didn't pack the nutrition punch for the effort that had to go into gathering them and soaking and drying and grinding and all that stuff. And they didn't feature either, really. And so we logically didn't evolve the enzymes needed to digest some of these foods. And so it's kind of no wonder that even today in my clinic, these two food groups, dairy and grains, are what I'd kind of consider problematic foods in many individuals, right? Our immune system kind of reacts as if they're foreign in a lot of us, okay? Another novel thing, this concept of 3 meals a day and 2 snacks, very new thing for the human genome, okay? And so I guess the message here is that, if you consider that line across the center, 2.6 million years of our evolution, about 150,000 generations. That little blip on the far right, that's 10,000 years, about 400 generations, okay? And so just not enough time has passed for our ancient genome to evolve to these new ways of eating. And in fact, the archaeological research shows now that Neolithic man was less healthy than Paleolithic man for some of those reasons that I mentioned, okay? So now I want to kind of fast forward to the next point in time where there was another kind of major departure from our ancestral nutrition, okay? This kind of farming and agriculture continued for several thousand years. So I'm going to skip over the Stone Age and the Bronze Age and the Roman Age and go to the next age where we saw this big shift, and that's the Industrial Age, okay? And with that age came the industrialization of food. 1800, only a couple of hundred years. We're talking now a handful of generations ago. And things like pasteurization, where we can heat dairy products and kill the bacteria. Great for shelf life, but we then kill the remaining digestive enzymes to kind of really get the most from it. So it becomes even harder to digest. We start refining cereal grains and sifting out the bran and the germ. And when we do that, we strip out most of the nutrition. You lose 85% of the B vitamins, 97% of the chromium, and on when you have like white flour, right? Same with vegetable oils. When we start industrializing and processing seed oils, we lose a lot of the fat-soluble vitamins. And so now these foods become really cheap and abundant, and so they enter our food chain en masse. Refined sugar, no genetic precedence in our hunter-gatherer evolution. Maybe a little bit of honey, but seasonality restricted access. So it really didn't feature much, maybe a few times a year, and it was not all cultures. So it's certainly not enough to change our Homo sapien genetics, okay? And then we start producing salt en masse, and that becomes really cheap. There was a time when salt was very expensive. I mean, we have to have salt to survive, but we only need a third of a teaspoon a day. And when we then start combining these foods, flour, vegetable oil, sugar, the backbone of any cake or biscuit, and you add salt. 75% of our salt consumption today is from processed foods, and these foods are largely devoid of nutrition, okay? We look at meat production. Prior to 1850, all beef was pasture-reared, grass-fed, and it took about 4 to 5 years to take a calf to slaughter, kind of grass, the food that cows evolved eating. Very slow growing. But then with all this grain, we got this idea to start feeding the grain to the cows, and grain has a way of fattening up mammals. Does the same to humans as well. And so we can start producing these really fat animals, and with that then came the concept of feedlots, and eventually antibiotics came in. 80% of the antibiotics that we use today go to livestock production. Eventually you start getting pesticides on the grains. Mammals have a way of protecting their vital organs by shunting toxins into fat, okay? So we're raising these obese animals, have toxic fat because they're fed pesticide-laden grains, and then some of the wacky stuff they're doing in America with genetically modified soybeans and growth hormone, we can take a calf to slaughter in 14 months. So this meat bears no resemblance to the wild meat that we ate as hunter-gatherers. Meat's been in the press a lot these days. We have to stop eating meat to save the environment. But I would say it's not the cow, it's the how that maybe is more of the problem, all right? So naturally, dramatic departure from our ancient genome nutritional requirements. And so there are some health consequences here, okay? Balancing our blood sugar, one of the primary tenets to good health, okay? And when we eat refined flour and refined sugar, and even things like fruit juice, I mean, how many people have sat down and eaten 3 oranges back to back? It's kind of difficult. Nature has a way of wrapping up sugar in lots of fiber, so we can't really get at too much of it too quickly. But when we down a glass of orange juice or have a slice of toast, we're basically spiking our blood sugar. That then stimulates insulin production, and insulin's the fat storage hormone, and these are risk factors for heart disease, right, long term. At the beginning, I mentioned these essential micronutrients, and the fatty acids that are essential are omega-3 and omega-6. And it's really crucial that we maintain a relative balance of those 2 fatty acids to promote health and prevent disease. And that's how our ancestors evolved. Today, with all the vegetable oil consumption, which is largely omega-6, the Western diet contains 18 to 1, 6 to 3. So that creates kind of an inflammatory house, if you will, right? And inflammation's at the heart of most disease process. Macronutrient composition, these are our carbs and fats and proteins. For decades, our government has been advocating 60% of our calories come from starchy carbohydrates. And that is the single biggest driver of type 2 diabetes and Alzheimer's and dementia even. The sooner the government shifts those guidelines to include more healthy fats and proteins and less starchy carbs, the sooner we start reversing the type 2 diabetes epidemic. And 2/3 of the population today failed to meet the recommended daily allowance of many micronutrients. And I would argue that RDAs are what I'd call minimum wage, right? When we look at sodium, we always talk about salt kind of on its own, but you can't really talk about sodium without potassium because they work together to regulate our blood volume and our fluid levels and our kind of nerve cell signaling. Again, our ancient ancestors got 16-to-1 potassium to sodium because potassium comes in plants. Today, with all the salt being added to processed food, we get more sodium than potassium. So, health consequences. And fiber, it's estimated that hunter-gatherers got 100 grams of fiber. The guideline today is 30, and your average Brit gets 18 grams. So, no wonder we're all constipated. So, I know this is kind of gloom and doom, these last couple of slides, but there is good news, all right? I know I kind of mentioned that there just hasn't been enough time for the human Homo sapien to evolve to this new way of eating, but I kind of fibbed a little bit because Homo sapien has evolved to this type of food, and it's a species that I call Homo Hitchcockian, and arguably a superior being in many ways. Now, I do want to kind of shift gears and give you my thoughts around how we can protect ourselves from this kind of genetically incompatible way of eating and living. And there are a good dozen principles to optimum nutrition and health that I give in various talks, but I don't have time to cover those. So I wanted to pick one principle that, if you cover this, you got most of it cracked. And I think this one doesn't. It's based on the good old 80-20 rule, which is to base around 80% of your diet around whole foods. And my definition of whole foods is any food where there's just one ingredient, really. A peach is a peach. A chicken leg is a chicken leg. There's only one ingredient in broccoli. But what on earth is a quaver? I counted the ingredients. There are 20 ingredients in a quaver, all of them heavily refined, except maybe pepper. And does anyone know what disodium 5-ribonucleotide is? I mean, I don't either. But it must be safe because they fed it to dogs and it didn't kill them, so we can stick it into quavers, right? But the truth is, when we base our diet around whole foods, it occurred to me, we pretty much, we balance our blood sugar. We get the fatty acid ratios right. We get the macronutrient ratios right. We dramatically increase our fiber and our potassium and our micronutrients, all right? We've all heard the government guideline 5 a day. That's based on science that shows that people who eat 5 servings of fruits and veg a day have less disease than those who don't, okay? But the same research also shows that those who eat 7 a day get even less disease. And 10 a day, disease almost falls off the cliff, okay? So I consider 5 a day kind of minimum wage. And sadly, most of us don't even get that, right? But a good rule of thumb is, because nutrients are color-coded, so if you kind of work your way through the rainbow, as many colors in the rainbow each day as you can, and I'm not talking Skittles, right? You're going to get kind of a diverse range of nutrients, okay? But I know it's not all about nutrition, okay? The longer I'm in this game, the more I know nutrition is about a quarter of the equation, okay? Also important to how we move our bodies, how we think, how we sleep, right? The best diet in the world, if we're not chewing it properly, we don't really extract the nutrients. There are no teeth anywhere in the digestive tract other than the mouth, right? And by eating on the move, which so many of us do, we tend to not chew. And when we eat when we're stressed, we make stress hormones that shut off digestion. So it just kind of passes through, and the best diet in the world is kind of getting wasted to a certain degree. We all know the importance of exercise daily, right? Even if it's a brisk walk at lunchtime and another before dinner, and optimizing our sleep. Sleep so easily gets thrown under the bus, and it's just critical to every aspect of health. So it's making sure that our rooms are darkened and ventilated, that we shut off our devices a couple of hours before bedtime, so we start to kind of tell our nervous system that we're winding down now. These are sleep hygiene tactics to kind of improve the quality of our sleep. And what we think about shows up in our life as well. So it's focusing on, fostering an attitude of gratitude, I call it. It really goes a long way to helping health. And I just want to leave you with this one last little piece of wisdom, British Airways wisdom, I would say, particularly important for this room, who are responsible for so many young people, including your families, and that is to make sure you put your own oxygen mask on first before helping the person next to you, because nobody wins when you guys are throwing yourself under the bus, okay? So with that, I want to say thank you very much for your attention.